Okay, as mentioned, my name is Paul Harris. I'm the lead developer on Cloud Foundry Java Client. Not, as was tweeted earlier, the whole of Cloud Foundry. That would be a bit generous. So what is this talk? It's an introduction to reactive programming. Now, I want to stress that from the start. This is an introduction. So if you're already pretty up on reactive and you know how it works and you know about Flux and Mono and all the rest of it, then you don't have to stay. It's okay to walk. We're going to have some background about where reactive comes from. That's going to be pretty short, and after this morning's keynote, it's going to be even shorter. We're going to look at a practical example, coded live, and I've just realized I've never coded standing up before, so that'll be interesting. And just to stress again, this is for your benefit. So if this is too simple for you, please leave. If it's too complicated for you, I guess please leave and see me later. So why am I presenting this? I've been using Project Reactor, the rebooted version that was mentioned earlier, for about 3 years, over 3 years maybe. We started on the Cloud Foundry Java client at the same time pretty much as Project Reactor was being rebooted, which means we were its first customer. We had a huge input, I think, into how it worked out, the various real-world decisions that were made, which I think made it better and certainly made the Java client much better. Because I started 3 years ago, I didn't have any background in reactive. It wasn't, that much of a thing back then. So I would guess I have made all of the mistakes that it's possible to make when programming reactively. And I may well show a few of them to you today. The final thing to say is that I'm a normal developer. You've heard a lot about the rock stars. I'm just like you guys. I picked up this thing because I needed to pick it up for work, and here's some of what I've learned. So, to clarify, I'm not a Java ninja, I'm not a Java wizard, I'm not a Java Jedi, or a Java Pooh the Bear, for that matter. I am none of these things, just one of you. Okay, so this all started out in 2013 with the Reactive manifesto. Which was an attempt to codify some of the thinking that was going on at the time about how modern applications should behave. The manifesto came up with 4 main ideas, 4 concepts. Applications should be responsive, so that doesn't mean that they should be as quick as they possibly can be, but they should always feel like they are making progress. So if you have to trade off a little speed for a little bit of feedback or something else like that, then that's okay. They should be resilient. So if you have an error in a particular part of your application or an application within a larger system, that shouldn't take the whole thing down. You should be able to cope with that as best you can. It should be elastic, which is, I'd always thought of that as being kind of scalability, really, but there's more to it than that. It's about making the best use of the resources you have available. So one of the keynotes this morning, Ben was talking about the having multiple threads running and being able to, with existing models, you tend to be CPU bound because you've got all these threads, all this memory, all this contention going on, and you're not actually using the CPU that you've got available to you. So Elastic is about making better use of things like that, pooling various connections, all this sort of stuff. And finally, it should be message-driven rather than event-driven. So manifestos are great, but they don't compile. I've got a message up here telling me I've got 11 minutes of speaking time left, which is a little concerning, but I'll try and go faster than that. The next step in this adventure was reactive streams, which defined a set of interfaces for how we might deal with reactive streaming situations. They define 4 main interfaces. You have a publisher, which is something that emits things. That can normally be data, so it can be strings or whatever it might be. But also, you can be emitting signals to say, this signal is complete, or whatever it might be. You have a subscriber. That's the thing that listens to the signals that are coming in. If you put those 2 together, then you have a subscription. So a publisher communicating with a subscriber is a subscription. The key point to make there is that a publisher is setting up the potential to publish information. But until you get a subscriber attached to it, then it's not necessarily publishing that information. The way we generally work with imperative code is you write a program, you run it, and it starts doing stuff. And generally speaking, with reactive programs, it just gets ready to do stuff and waits for this signal that it should actually consume the results. The final type that they defined was a processor, which is a combination of a publisher and a subscriber that allows you to process data. Okay, that's the basic interface definitions, but the intention was from reactive streams that would move on to a more useful real-world implementations of that basic specification. And one of those is Project Reactor. So it's turning reactive streams into a framework you can actually use and that has all sorts of convenience methods in there that will be helpful to you. I took a look back. The first commit was in 10th of November 2015. I mentioned that to illustrate that this is a major project that's been going on for 3.5 years now. 4.5 years? Maths. So this is not a casual undertaking. It's something that Spring's taken very seriously, and I think that's reflected in the quality of the reactive frameworks that are now available to you through Spring. There are many elements. A couple of new ones, one I hadn't even heard of before, were mentioned in the keynote this morning. But probably the three big ones that are of main interest is Reactor Core, so that's the basic provision. Reactor Netty, which is the implementation of Netty suited to Project Reactor, that if you're coming from the Web MVC world, that replaces Tomcat as the server container, and the final one is React Test, which is a bunch of really good, useful methods for testing reactive streams, which is a tricky thing sometimes. So, before we get into the code, there's a couple of key concepts to understand. I mentioned earlier about publishers, which is this reactive streams idea. And in Project Reactor, they decided to have two specialized publishers. So you have a sort of a general one, which is a Flux, and we've seen those mentioned already today as well. And the Flux is essentially the same as a publisher, with many methods added on and so forth. It will emit 0 to n elements. It's unbounded, so it will potentially keep emitting until the heat death of the universe, I guess, or until it's run out of data that it needs to emit. There's this more specialized type, which is a mono, which is a publisher of 0 or 1 elements. So the reason this was done was mainly as a sort of a real-world decision that not everything is a flux. You know sometimes that you're making a call and you're expecting to get back a single value, or potentially no value at all. So for code optimizations and for being able to work in the real world with this tool, it can be handy to narrow things down and say, here's a mono, so here's are the methods that are specific to this particular thing. And I found using it that it also helps me to get into the right mindset, that if I know I'm dealing with monos, then I'm thinking in that way of, okay, I need to think about one value coming back, and I need to handle the fact if nothing comes back, and that's a separate case. So it's both from code and from a philosophical perspective, I guess, it's quite a useful distinction. So we're going to look at both of those in a moment. So here is our simple application that we're going to use for the demo. And I'm going to try and make that much bigger. So it's a Spring Boot application, as you can see. It doesn't particularly have to be. It's just a convenience. I'm sure I don't need to tell all you folks about the benefits of using Spring Boot. I have a repository of employees. I'm using JPA repository. I can see if I have to do this again, I'm already going to have to convert that to Spring Data R2DBC. We have an object of employee. Very simple, just name, pension ID, and role. You can see I've used the @data annotation there. That's a Lombok thing just to save me having to generate getters and setters and so on. Again, not required for this. So that's all the details around it. And now for the actual code. So we have a REST controller. Let's get rid of some of that. And we have a number of functions in here. Now, I should point out this is a demo app. It's not terribly well structured. I just wanted to get everything into one class. So If that's making you feel sad, then just think of it as legacy code and we'll fix it later. We have another number of functions in here. We can do a mapping to employees where we say, give me all of the employees, and it just spits out a list. We can search for an individual employee and give it an ID. We get back an employee or a message saying that that employee couldn't be found. We can search for problem records, where we go through and look at all of the employees in the database and decide if there's something wrong with their data, say they've got a missing data entry or a spelling mistake or something like that. We can create a new employee. This is interesting because we have this pension lookup that will call out to a service and give us a pension ID based on that person's name. So we've got a little bit of communication there. And finally, we have, excuse me, update pension records. So rather than with the new employee, we go and get a specific record for that employee, we can update all of the employees' pension records. So we call out multiple times to this service to get the IDs that we need. And then down at the bottom, we've got a couple of convenience methods. So we need to take this imperative code and make it something that's reactive. And step one, because we're at a spring conference, is we open our POM. And at the moment, we're using WebMVC to provide all that get mapping goodness and all the rest. We're going to get rid of that, and we're going to add a dependency to Spring Boot Starter WebFlux. So whereas before you're all used to having WebMVC, we're now using WebFlux, which is essentially the same thing. Clearly, there will be differences because it's dealing in a different model of programming, if you like. But it is the non-blocking, asynchronous, the reactive approach to doing what WebMVC does. Something that I've seen highlighted a couple of times is to point out that WebFlux doesn't replace WebMVC. WebMVC is not going anywhere. This is just, if you're doing a reactive style, then this is the thing that you should be using. So we've changed some dependencies. We'll start running. And if we take a look at the console, we can see down here that we've started Netty on port 8081. Previously, it would have been running on Tomcat. And if we go over to my little test suite, I can run the various queries that we were running, that we have available to us, and we can see that data comes back from them all. So I can get users, I can create myself as a user, and I get back my pension ID, that's great. I can search for problems, and I'll get a list of all the users who've got issues with them, like a missing role, for example. I can do a search for a user that I know exists, and I get back that user's details. I can search for a user that doesn't exist, and I get back a 404 because that user wasn't found. And finally, I can do a pension clean, which connects to a slow connection. I know it's slow because I put thread sleeps in there. And I get back, I get back the results showing me the updated pension information. And if I take a look over here, I've got a sysout in there that tells me what thread I was using. So I was using one thread for all of the calls that I did to this slow service. Nonetheless, I'm now running on Netty. I've enabled WebFlux, so I guess that means that we're now reactive and we can all finish. Not quite. It is impressive to me, though, that although this is quite a simple application, we didn't have to change anything. All of that still runs because all of the functionality that we're already using, I'll find the class, there we go, all the functionality that we're using still exists. So it's not necessarily a huge explosion if you decide to move over. You can start doing it a little bit at a time. It does depend on if you've been using Tomcat-specific or particular servlet features, obviously, but in general, it tries to make the transition as easy as possible. Having said that, we do actually need to start using things like Flux and Mono to find out what we do next. So we'll start off with the simplest query that we've got, which is just to list all employees. And at the moment, it's got a list of employee, and we just call the repository, and it just dumps everything back to us in the form of a list. And then WebMVC converts that into something that we can display on a web page or in my REST client. So the first thing we need to do is say, well, we're not dealing with lists anymore, we're dealing with Flux. And immediately that gives us an error, because this return repository find all is still doing things with a list. So we need to work out some way of converting that into a Flux. Handily, something that's not particularly in the Reactive Stream spec, because that's a very high-level document, but is added in Project Reactor, an example of one of the things that it will give you for free. We have a method that we can call to do that. So we start with a Flux, and we choose from iterable. And because repository find all returns a list, that's an iterable, nice and easy. So we can put that in there. Oops. Get rid of that. Make sure we're returning it. And when I restart, I should explain, I've been working in Go for the last few months, so if I miss out some semicolons, don't judge me too harshly. Clearly there should be a semicolon in there, just do it for me. If I then make my get recall again, get call, then I get the same list that I had before. So those of you who are thinking back on what I was saying earlier will have noticed that we've got a publisher, but it doesn't appear, based on the code, that we have a subscriber. In much the same way that WebMVC takes this basic get mapping and turns it into something that we can provide to a web page or to the Cocoa client, the webflux is doing the same thing. It is the subscriber, so whenever it receives a call, it initiates that subscription and says, give me the data that you've got for this endpoint. That's fantastic, because keeping control of subscribers can get a little complicated, and that's one of the things you can look forward to in your future if you're using Reactive. Project Reactor makes it as easy as it can, but there are still some tricks around knowing what thread you're on and making sure that you've closed down things. Okay, so we've done that. I have notes as well. Let me just make sure I've not forgotten anything on there. So we started that by beginning our entire flow, as short as it was, with a Flux. Now we're going to look at a similar case, but we're going to start with a mono instead. So we're going to look at the find an employee by ID. And at the moment you can see it finds by ID, throws an exception if there's a problem. I had 404. So we might want to do something similar to what we had before. And we could try something like this. We say, mono just, so I just want you to give me a mono, and I want you to create that mono from repository, and we give it an ID. But there's a problem with that, and the problem is that find by ID returns an optional, because it doesn't know if it's going to find anything or not. And handily, we have a method that will handle that situation, which is just or empty. And what that says is return the mono that you get back from whatever call this is, but if you don't get anything back, then just return an empty. So the key thing here is that we're always dealing with monos, so we need monos to be passed around. So if we don't get something back, we don't want to have an error from it particularly. We just want to say, here's what I got back, which was nothing, in a mono form, and you can carry on. We still also need to have this exception. And we can do that in a slightly different way to the imperative style by saying, okay, we know we might get back a value, and that's fine, we can just pass that on. But if we don't get something back, then we want to switch what we're providing by providing a new mono that we can use. And we are going to do and I've done something terribly wrong. So I shall look at my notes and make sure I can fix it. Yeah. There we go. When I said that I have made most of the mistakes that you can make in using Reactor, one of the first mistakes that I think I made was to forget that we're not returning an employee anymore. We're returning a mono of an employee. So we now have the same functionality that we had before, but instead of throwing an exception, we are returning either the value that we got, or we are passing on a mono of an exception. This is an important thing about Project Reactor and reactive programming, that errors are values, just the same as a string or an employee or anything else. As part of that resilience we mentioned earlier, you don't necessarily want to panic just because you've found an error. You want to pass that on to somebody, perhaps several chains down the line, that has the ability to deal with that error in a sensible way. So for us here, we're just going to say, I've got this error, and you should do with it what you want. So if I run that, and this is doing a search for a user, so here's a user that exists, and that's fine. Here's a user that doesn't exist. So I created this mono of an error and passed it on, and I've passed it on to webflux, which is the thing that's doing the subscribe, and it's decided that when it sees errors like that, it will pass them on to the user as a 404 employee not found. So just to emphasize there, errors are not, they are just values the same as anything else, and you need to pass them on as you would a string or an employee or whatever it might be. The next one we can look at is find problem records. And again, we're going to avoid the first mistake that I made earlier. So we want to return a flux of employee. And obviously that causes a problem because that's not what we're doing anymore. So we need a flux. And we already know of a method that will generate a flux for us. And then we want to do something with this list that will get rid of all the employees who are fine, who are good, and we'll just leave the ones that have problems with them. Now, in the imperative code that I was using earlier, you can see that I'd created a couple of lists. One of the result that I initially got back from my repository, and then a second one where I could put all the users that were problematic to pass back. There are various ways of doing that. The reason I'd chosen this was because some of the other ways of doing it can cause concurrency problems that if you're trying to update a list that you're also reading from, then things can start to trip over. So we want a way that is not going to cause that sort of problem using a reactive flow. And ultimately what we want to do is to filter the results that we get from this initial flux so that we can discard anything that doesn't meet our criteria of having a problem with it. And handily, there is a filter. So that filter takes, oops, I can't spell, an employee, and we'll do something with it to perform a test on it. And it checks to see whether that employee has some problems. An important thing to note here is that once we get into the filter and we have this employee, this took me a while to fully wrap my head around, I've made that singular for a reason. Although we have a flux of all of the employees, once it gets inside the filter, then it's just dealing with a single employee. And we'll have, if you imagine, as many filter instances, it's not really an instance, but that's the idea, working on this flux, each dealing with a particular employee as it needs to process all of the data. And what happens is that each of those filter instances will drop one of the employees if it says, yeah, that's fine, it passes my test, or we don't have a problem with this particular user. So what's left behind after we've done that is just a flux that contains the users that do have a problem. We've discarded all the others. Which means that this code is now complete. It actually surprised me when I first did this. I thought I would have to have another line. But we've got rid of everything that doesn't meet the criteria we want. So all we're left with is a problem employees. And that's still a flux, because we've just filtered the flux. We haven't changed it in some way. It gets passed on to webflux, and again, it presents it to whoever's calling it. One little thing that will probably be upsetting some of you IntelliJ purists. Because I'm passing in an employee to a method that only requires an employee, we can do a simplification of the code like that. Okay, so the next thing we can do is a new employee. This one's a little trickier because we're making this call out. The first thing we might think of doing is saying, well, I need a name. That's fine, I've got a name. And I need the pension ID for that employee. Okay, well, I'll do new employee. Oh. Let me try this again. I need the pension ID. And I can do a pension lookup on it with that name. And then, well, I need that value. So how do I get that value? And this is where it kind of starts to go wrong, because I'm not programming in a reactive style. I've started in an imperative style. And what I actually want to do is start somewhere with either a mono or a flux to say, this is the flow that we are doing. So what I want is something here that will provide me with a mono. I could just create one with a mono just, as we've seen already. But actually, there's going to be some code here that will provide me with a mono if I start making some changes. At the moment, we're using a REST template, which is perfectly fine, reasonable WebMVC choice. But as we saw in the keynote, actually, it is a blocking call, which means that we act on a single thread. It's not really reactive, so we need to change that. And the way we change that is we will have the web client that was mentioned earlier. And we would like, wouldn't it be great if Spring Boot could provide us with one of those? Can't spell. And then we want a web client. Let's capitalize that. Like I said, coding standing up is a very weird art. Client builder. Okay, so we've got a basic one. There's all sorts of configuration that we can do on it. We want a base URL. And I know that that is localhost 8082. So that's all I need to create my web client. Spring Boot in the background is doing all the magic for me to give it sensible options. If I go down to my pension lookup, clearly this is now out of date because it's using the REST template. So instead, I need the web client. I'm going to do get. The URI I'm going to call, so that's an extension to the base URL, is name. I'm going to parameterize that. Then I'm going to retrieve the result, and I happen to know that the result that comes back is just a string. It's nothing fancy. So I'm going to body to mono, and it's a string. And again, we've got the error because I'm saying that this is providing a string, and no longer it now provides a mono of a string. And again, Go programming, we'll put in that semicolon. So now we've got the infrastructure set up, we can go back to our code here and think, I've just created something that will provide a mono for me. So why don't I start with that pension lookup that's going to return a mono? I can get the name, that's easy enough, it's in the new employee. And then I want to do something with that. And the way we very often will do something with that is to use Flatmap, which says, I'm going to do reactive work on this piece of data that you're passing in. In Mono, it's a little odd, because one of the implications of Flatmap is I'm going to create a number of processes that will deal with each of the items that you're passing into me. And for Mono, we know that's going to be a single one. Nonetheless, that's the same pattern that we want to use across both of them. So I'm going to get a pension ID from that. Incidentally, something that took me a while to work out, I've called that pension ID. You can call it P if you want. It's not a particular value. It's just a name that you're assigning. If you've been using Java 8 streams, for example, then you should be very familiar with that idea. So I want to do something with this pension ID. I want to make sure I get it right as well. Okay, I want to do two things. I've got the new employee. I want to set its pension ID to be that pension ID. And now, an important thing, I want to return something that my flow can continue with. And in this case, that's fairly straightforward. I can use the new employee that I've got. And finally, I need to do something with that employee. And I want to save to the repository. In fact, I can do that more easily. And again, I want to return a mono of employee. Oh dear, that's the wrong, isn't it? There we go. There we are. As I said, normal developer, make normal mistakes. So that bit of code now should be okay. We've got a flat map there, which says I will take each individual item that you send me, being just one in this case, but it could be many, and I will do whatever process you tell me to do on it. And then at the end, we have a map, which is essentially a synchronous call for trivial behavior, if you like, that just says, save it to the repository. We're done. So we have a very similar method that we want to call, but instead of just doing one pension update, one call to the pension service, we're going to do multiple calls. So we need to do a similar conversion on that. And if we first change that so I get it right. Were you all feeling tense about that return that I put in the wrong place? I could feel a certain concern. So again, we know how to create a flux that will have some information that's interesting to us. We can start with a find all. And then, as we've just seen, we're going to do a flat map again because we want to do something with the values that come out of that iterable that we've turned into a flux. This time it's a little more interesting because we're actually going to get multiple values out of it. So if we take, we're going to get an employee out of that. And we're going to want to do something with that employee. Again, I want to make sure that I get this somewhat right. So let's do that. We're going to do a pension lookup on it. And we need the name so that it can do the pension lookup. And then we want to take the result of that and do a flat map. This time it's a mono because we're just going to get one value back, but it's buried inside this flat map we've got going on. So we'll get a pension ID come back from that. And much like the code that we just wrote, we then want to do two things with that. We want to update the pension ID with that value. And again, we want to return an employee so that the next step has something to work on. And again, the final step that we want to do is to actually save it. And I need another thing there somewhere. $16? $60? 66. Oh, thank you. Do you have returns in Go? I can't remember. Okay. So this is the more interesting one because I still need my, there we go. This is the more interesting one because we're using Flatmap more for the impressive purpose that it has. That we start off, we've got employee, and we're going to take each one of those individual employees, and we're going to do the pension lookup for it, update the record, and save to the repository. So if we've got 100 employees that we need to check the details on and update, then it will potentially spin up 100 processes that will be able to do those in parallel or as close to parallel as it decides is appropriate. A lot of the work that's gone into Reactor is making sure that it has good defaults for things like the number of threads. I think it was mentioned earlier that it's typically the number of physical CPUs on your machine. So all of that is something that you can tweak, but you should probably think about that and first get used to the programming method in general. So if I try and run that now, oops. Then with a little luck, we did our create a user. I should probably restart as well. That will help. No obvious failures. I must have the right number of semicolons in there. So when I do my call, again, it works same as it did before. Looked up the pension ID. If I do my clean, so I make multiple calls out to the pension provider, you may notice that that was quicker. And that's because if we look over on the oh, I forgot to put in the thing, didn't I? I'll just steal this piece of code. There we are. again. So I'll make that call, and if I look down in my console, in the size that you can see, without me having to think about coordinating different things that are going on, Reactor has taken care of the threading for me. It's used 4 threads because this is a 4-core machine, or 4 CPU machine, I guess, and has made the process faster without me having to think about anything, and it just happened by magic, or almost by magic. Okay, so let's have a quick summary of what we've been doing there. We had a quick look at what Flux and Mono are. The important thing being Flux is a 0 to many, Mono is a 0 to 1. It's a different way of thinking about it. Limits down the options that you've got, helps you to think about processing individual items. We looked a little bit at map, which is doing that, that synchronous call, and the Flatmap, which is part of the real cleverness of Project Reactor, of sharing out this workload and then bringing it all back together so that you just get a single flux at the end of it that can then be processed. Errors are just values. I stressed that at the time, so we want to be able to be resilient, and we can do that if we're passing around errors rather than just exploding as soon as we hit upon something. A key thing that needs to be emphasized is you should stay reactive. So we start each flow by coming up with some sort of flux or mono, and then we try and stay in that pattern. One of the most common mistakes that people make is there is a method on a flux or a mono called .block, which lets you retrieve the value at that time. And particularly if you start to get into more complicated flows, what stuff we've seen here is quite simple. You get halfway through and you think, I just need that employee name. If I can get that, then I can do the rest of this, and you put in a .block. Back in the day when I started with it, it was called .get, which was far too tempting. Now block, we're starting to realize block is a bad thing, so you try and avoid that command. And there will be a way to follow through the logic of staying reactive and making your entire flow reactive. One thing we didn't get to too much is it doesn't replace what you know. You can still use Java 8 streams if you want to call a method that does some processing, as long as that method returns a mono or a flux, depending on what you're doing. You can have if then else inside there. You can do streams to manipulate strings or whatever you might be doing. So this builds on what you know. It can be really intimidating at first. One of my colleagues described it as when you're learning Java, there's quite a shallow learning curve, and then to get really good at it, it gets really steep as you're getting into all the complex options that Java provides. Reactor's kind of the opposite, that it starts off really complicated because it's a whole new way of thinking about how to create flow. But there are relatively few commands available to you. I think there's between Flux and Mono, there's maybe 200, something like that, many of them shared. So it's actually possible to get a grasp of pretty much everything that Reactor offers. Some resources for you. There's the Reactive manifesto and the Reactive streams that we mentioned earlier. Project Reactor's home itself. Really good documentation on there, not just the Java doc and stuff like that, but it really takes you through, here's what a flux actually is, here's what we mean when we flat map, what we're doing underneath the covers. Something that I particularly like inside there is the choosing an operator page, where you can sit there and say, okay, well, what I want to do is to filter the output that I'm getting here. And say, oh, right, well, you need to use a filter then. Really useful when you're first starting out and you just don't know what any of these things might mean. Reference to the Spring Web Reactive. The code for this presentation will be at that URL. It's not there yet, but I'll get there. And the final thing I wanted to mention, as I said at the start, I started out with Reactive on the CF Java client. Because it grew up with Project Reactor, it is an excellent resource. I'm not boasting, there were many more people than me involved in it. It's an excellent resource of examples of how you actually do reactive when you've got complicated code, when you've got the sort of branching that I didn't even dare to get into today. Wander through there, particularly if you have a look through the integration tests, which are pretty extensive. You'll get an idea of what you can achieve inside Project Reactor. So the clock down here, I think, has been corrected and now tells me that I have 10 seconds left. So all that remains is for me to thank you, so very, very many of you, for being here for my first ever live coding session. I'm going to be hanging around the back if you need me, and there's one or two of my colleagues who will also be able to help out with any questions you have. Thanks very much.